my video for the class. Cool. So your book for this class, I would like you to have this by Tuesday or Wednesday next week. Looks like this. Business calculus. It's 10. We'll get most of it done. Okay, but this will be your book to have for this class, okay? Make sense? You know where to get it? Okay. Financial hardships. You let your counselor know. They'll give you a coupon, and they'll take care of you. So let's take a look at these first problems. All right. I'm going to go right to Desmos right away. Deal? Because let's face it, they want us to factor these. Agree? And factoring is all fine and dandy until you get that sinking feeling going, I'm really good at factoring, until you realize you're not. Now, you're always welcome to use a laptop or a tablet if you want to use Desmos. It makes it a little bit easier. I want it on your phone because I know you always have your phone. Desmos is a little easier. So let's kind of cheat the system a little bit and reverse engineer how to factor. Deal? So if I want to type, I realize it doesn't say y equals, but I'm going to do y equals that very first problem. And so I get this, and I'm going to make this a little bit thicker. So mainly the most important things in calculus or in math are where it crosses the x-axis or turning points. Okay? So the nice thing about Desmos, if I click here and I click here, it gives me two places in which it crosses the x-axis. Agree? And what I could do is I can pinch this down and I say, hey, look, it's a parabola. Sweet, it's a parabola. It's way down there. Desmos is very easy to pinch and release, but you can find where it crosses the x-axis. And if you see where it crosses the x-axis, you ignore the y component, the y component is being 0. So basically what this means, if I shift to this board, means that x is equal to 7 and x is equal to -7. Reverse engineer this. So this becomes this binomial because I subtracted 7 from both sides. This becomes x plus 7 because I added 7 to both sides. And friends, that's already factored. Now, the thing is, you might know that as difference of two squares. You're like, Stirrup, this is obvious. I know how to do this. I got you. I got you covered. Anyone not follow what I just did? Wait a minute. You're waiting for the hard stuff to kick in. Sorry, I'm not going to make it hard. Let's look at the second problem on your packet. You still with me? Did everyone get a packet? I didn't forget somebody. You know, I have that one kid sitting there going, hey, I forgot me. All right. Let's go back to Desmos. Let's change this. Let's change this to x squared plus 4x minus 32. So you have two important features. You have where it crosses here and where it crosses here. Okay? You know those become the solutions to the problem because the y component is 0. So I get x equals -8 and I get x equals +4. Does that make sense how I just said that? So -8 and +4. So if I go back to this, I have x equals -8, x equals +4. Add 8 to both sides to get this. Subtract 4 from both sides to get this. And friends, don't you wish in Algebra 1 and in Algebra 2 they would have let us use Desmos because this factoring is so easy. There are so many different rules with factoring that are tricks to it, and the tricks don't really show you the understanding of what a factor truly is. Desmos does. Yeah, but my math teacher I had 2 years ago, she was awesome, or he was awesome. I understand, they were. Hopefully this guy will show you a few other ways. Let's take a look at problem number 3. You follow me so far? If I go too fast or if I need to go back to something, let me know. But notice the main thing I'm doing on these, I don't have y equals, but I want to graph it. So I'm cheating the system to see where it crosses the x-axis. So I get 4x squared minus 13x minus 32. That's what this looks like. And I have two values here. I have a value here. I have a value here. Like, What am I supposed to do now? Well, in this type of notion, our way is not going to work. I'm glad the vape detector.
Yeah, I was
What happened?
It's plus 3 on the packet instead of minus 3.
Oh, I'm mixing problems together. Does that work better? Oh, this is cool. Okay. All right. Oh, I feel so much better about myself. All right. 0.25 is the same as what fraction? 1/4. Feel okay? And then 3. So we have 1/4, x equals 1/4, and x equals 3. Agree? All right. So x equals 1/4. Does everyone understand how we get 1/4? It originally says 0.25, which basically means you go 25 over 100, which reduces to 1/4. And what was the other one? 3. Okay. And x equals 3. So let's reverse engineer this. Multiply both sides by 4. You still following my adventure? So I get 4x is equal to 1. Subtract 1. 4x minus 1 is 1 factor. Subtract 3. X minus 3. We just factored it. Now notice I cleared the denominator to get it nice and neat. And if you were to FOIL that out, our 4-letter F word in math, FOIL. There we go. 4x times x squared, I get 4x squared. Hey, it works. Outside is 4x times negative 3 is negative 12x. Negative 1 times x is negative 1x. Adds it together to give me negative 13x. Negative 1 times negative 3 is positive 3. Seem to work okay? All right, let's bounce down to number 6. Can I move off the screen? Number 6. This just got real. Now, if you try and graph this on Desmos, it's going to give you something really wild and entertaining to look at. Basically, what you're looking at in this situation is you're looking at something in the 3rd dimension in the x-axis, something in the 5th dimension on the y-axis. What's this dimensions I speak of? I mean, you guys know 3D. We're all in 3D right now. Some people are like, yeah, but isn't time a dimension? Yeah, time is called a half dimension because we only know how to go forward in time. We don't know how to go backwards in time. Definition of a dimension is something that you can go backwards and forwards. You can go left, right, up, down, front, back, and then time goes forward. So theoretically, right now, by definition of dimensions, we are living in the 3.5 dimension. Okay, we have time as a half dimension because we're only going forward in time. You know, like, what are you even talking about? So on this one, what I want us to do is I want us to think about, okay, I'm going to realize I have this if I just talk in the x's. And if you plotted this, this is going to do something like this. Okay? Where it's very possible that this right here might be something called a bounce. And then we might have crosses that take in place. Okay? But easier things to look at on this problem is don't fathom this problem on something to graph. When you have multiple letters in there, break things down. 10 is the same thing as 2 times 5. Agree? X to the 3rd is x, x, x. Agree? Y to the 4th is y, 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 y. So that's the exact same thing as this if I multiplied it all back together. Then if you take a look at this, you realize you have a minus sign. 25 is the same thing as 5 times 5. X squared is xx. Y to the 5th is y, 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 y. And then what I want you to do with this, and it's funny, I'll go to math conferences, and this is exactly how I do math. And people are like, why are you doing it that way? And I'm like, getting the answer right. They're like, yeah, but you should do it this way. Why? So, I have a 5. I have XX. I have XX. I have Y, 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 Y. So, the things I highlighted we have in common. Just factor them out. I can pull a 5 out. I can pull an XX out, or x squared. I can pull a y, 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 y out, which is y to the 4th. What do I have left? I have a 2 and an x. I have a minus sign, and I have a 5, and I have a y. Friends, it's factored. But should we do it that way? But if you see it to do it another way, please by all means do it. If you get the same answer as me, you're always welcome. But I like teaching this to realize what I'm really looking at. And why did I highlight the second and third X, not the first and second X? I could have. Why didn't I do the first and third? I could have. I'm just combining, realizing what I have the same. And that's basically how I work through these problems. Okay? All right. Are you ready for your first adventure? So, this page that I have you, the page is called Page Algebra Review number 1. Still following? Which we've been working on. I want to make sure by tomorrow you have 1 through 9 done. And I just did a few of them. You have the rest of the period to work on them. You can ask me if you have questions. If you get stuck on something, ask me. But explore. Hey, friends, all I ask on your homework is you tried it. Does try mean you got it right? No, try it. Practice it. If you make a mistake, it's okay. We'll correct those mistakes tomorrow. Make sure we have them right. We feel comfortable about it. We feel comfortable about making mistakes because making mistakes is part of life, and it's really okay to make some mistakes. Hey, is there anything that you need to know about me that I kind of disclosed to you? I will tell you every other Friday, we will actually do a real-life math application. I will teach you fair division. That's kind of a fun one. I will teach you fair division is how you divide up a state division. I will teach you why it's not good to rent to own your stuff. I will teach you how to become millionaires, and it's not hard. I will teach you about mortgages, about credit cards. These will be different. About every other Friday, we'll have a real-life application. It might be related to the math we're doing. It might not. But I think you'll enjoy it, and I get to go into some goofy characters. So I would say Friday of next week, we will have our first situation. Everyone feel good about what we've done?